Hi, welcome to the topic on RHRS, that is Residual Heat Removal System. The primary function of the Residual Heat Removal System is to transfer the heat energy from the reactor core and the reactor coolant system, that is RCS, during the shutdown periods and cool down and throughout the refueling operations. Even after the reactor is shut down, the decay heat from the fission products continues to be generated. If the heat is not removed, the excessive temperature will build up and which causes the fuel damage or system overpressure. Here I am talking about the main responsibility of the RHRS system, that is the cooling of the reactor coolant system during some conditions. I will describe the conditions. The conditions we can be classified as: first one, shutdown cooling; second thing, reactor refueling operations; third one, emergency core cooling system; and fourth one, low pressure operation periods. When we go through the first one, the shutdown cooling, it means it maintains the safe temperatures after the shutdown periods. And the second one, refueling operations, it cools the reactor core after the reactor vessel open for the refueling purposes. And third, emergency core cooling, it provides backup cooling system when the loss of coolant accident occurs in the plant. And the last one, the low pressure operation periods, when operates at the reduced pressures, the RHRS will be engaged and it will helps to maintain the system at the limit periods. Let us discuss more RHRS operation in different plant states. We know the RHRS is primarily used during the plant cool down and refueling operations. Now we can talk about the RHRS operation during the normal shutdown and cool down. We can classify into three categories like that activity. The first one, initial cool down, and second, residual heat removal activation, and third, continued cooling until cold shutdown. During the initial cool down, we are using the steam generator to remove the decay heat from the RCS. Once the reactor coolant system reaches approximately 80 to 95 degrees Celsius, then the RHRS will be engaged. Then for the residual heat removal activation, the RHRS pumps take suction from the RCS, then water is passed through heat exchangers, then it removes the heat and back to the RCS loops. Then it will continue until the RCS temperature reaches up to 32 to 50 degrees Celsius, which is very suitable for refueling operations. The main components of RHRS consist of RHRS pumps, heat exchangers, valves and piping, and isolation valves. In this, RHRS pumps is using to circulate the coolant throughout the system. Then heat exchangers, it transfer the decay heat to the secondary cooling system. Then valves and piping, it directs flow between RCS and heat exchangers. Then isolation valves, it prevent the unintended loss of coolant from the reactor coolant system. You see in this diagram, as I said earlier, using the RHRS pumps, it removes the decay heat through the heat exchangers and it is going back to the reactor coolant system loop. So we can see here this RCS loop 4, from here it enters into the RHRS system and it back to the RCS loop. Then we can conclude this topic by saying the practical importance of the RHRS system in PWR. The main practical importance is it ensures the safe cool down of the reactor after the shutdown periods, and then it allows for safe refueling operations by maintaining low temperatures. Then RHRS provides the backup cooling in case of other cooling system fails. The last one, like we can say, it ensures compliance with safety regulations and plant operating procedures. Thank you.